What's up, everybody? Now you are watching part 2 of graphing quadratics, and in this video we're going to learn how to see and identify if the quadratic has a vertical shift from the parent function. Alright, so in this video we are working with example 2 because this is a part 2 of, I believe, 3 or 4 videos together, and we're going to graph y equals x squared minus 2. And we're going to compare what we get from this graph with the parent function of y equals x squared. So I use the default -4, -2, 0, 2, 4 as my selected x's. You can definitely use any points that you want, but I'm picking these points just to get a good shape, and you can use your TI-84 to actually get more accurate points than what I'm giving you here. So I'm going to substitute in my -4 into the x in my parent function. So -4 times -4, you get 16. And I quickly ran through that just to give you a heads up. -2 times -2, you get 4. 0 squared is 0, and then we come back up. 2 squared is 4. 4 squared is 16. Okay, so we're doing the same thing. We're going to graph these points. We can't actually graph a -4, 16 because 16 is way up here. So we're going to go to -2, 4. So -2 up 4. We're going to actually put our point down. And then go to 0, 0. And then 2, 4, and then we can't really graph 4, 16 because it's way up here. But imagining that your shape is going to come along the line. So we're going to graph or connect our points not in a V fashion, but in a curved, nice, beautiful parabola. Notice how the hand is kind of showing you how to shape it. That's quite fast. I don't know why I didn't slow that down. Let's see that instant replay. Beautiful. So now, there's our general shape of our parent function. So let's see what happens when we actually graph y equals x squared minus 2. So when we subtract 2 from our parent function. So our points we're still going to use is -4, -2, 0, 2, 4. So we already had -4 squared, quantity squared, so we actually just subtract 2 from that. So we get 14. Let me speed that up. And then we should get 2. Should get -2, sorry. And then we should get 0 here. And then we get 14. So again, if you're kind of confused of how I got these points, I substituted in -4 into my function. So -4 squared is 16 minus 2, you get 14. -2 quantity squared is 4, minus 2 is 2. 0 squared is 0, minus 2 is -2. 2 squared is 4, minus 2, you get 2. So on and so forth. 4 squared minus 2 is 14. Or 4 squared is 16, minus 2 is 14, excuse me. So I'm going to graph those points in red. 14 is way too high, so -4, 14 was not going to be on this graph, but we know it's going to be way up here. But we can get -2, 2, and then we can get we get 0, -2, and then 2, 2 again, and then 16, 4. So we're going to go, oh my gosh, not 16, 4, that's a common mistake, and I just made that mistake too. Our x-coordinates are on the left side, so 4, 14 we can't actually graph. So we have 2, 2 from here, 2 and 2, 0, -2 from here, and then we have -2, 2, which is right here. We can't graph -4, 14 because that's way too high. So then connecting my points, and knowing that I have a -4, 14 point way up here, I'm going to create a nice slow parabola connecting my points, not in the V formation, just like so. So if you notice, the shape of the graph is pretty much the same. I mean, it looks a lot wider just because it's outside of the original parent function, but notice how our vertex has shifted down 2 units. And from our equation, if you look at our parent function and then our function that we have to graph, our quadratic, our x squared is just being subtracted by 2, so that -2 at the end, if it's minus anything, is going to give us a negative shift of our vertex. So when we compare our graph, we say the graph is, or has a vertical shift of 2 units down. So if we actually had a function where this is a +2 or a plus anything, where do you think the graph's going to shift? Good. Up. So if it's minus x squared minus something, it's going to be shifted down. The graph's going to be shifted down in negative fashion. And if it's x squared plus anything, we're going to shift the graph up. Notice how the coefficient of x squared is still the same thing as the parent, so then there is no vertical or horizontal stretch. So the fact that we have a minus 2 at the end after x squared gives us a vertical shift down. Thanks for watching, guys. Make sure you watch part 3 now, where we'll have a reflection, and maybe a vertical horizontal stretch, or even a vertical shift in our graph.